Hello and welcome back to the Data Science Castnet. I know I haven't made any videos in a while. I've been frantically busy on the Generative Landscape course, which as you can see from the post-it notes behind me, still a lot of things to do before that's ready for launch. But I was going kind of crazy, so I decided to do something different and make this video exploring ways of editing images using diffusion models. So diffusion models, very powerful, often with text guidance, so the ability to type in some text and generate an image. So these are really great, but you also see them applied to what if we don't want to just generate an image from scratch? What if we'd like to edit an existing image? And so in this video, we're going to do a very high level look at some of the different techniques available. I'll skim past a lot of papers. I can't guarantee that I've read them all in depth, so there may be mistakes, but I'll link them all below so that you can double check and read more. But I just wanted to give an overview of the many different approaches that are emerging in the literature. And so before we even start, I wanted to call out, this is not going to be something completely new. Even before diffusion models were a thing, people were exploring, for example, VQGAN plus clip to take in an image and then to iteratively update it based on a new text description, optionally adding some perturbations and things. So anyone who claims to have invented this task with diffusion models is slightly over-exaggerating. This kind of semantic editing where you keep the overall structure from some input, but you have new texture or new ideas, that's been around for a little while, and we'll see some variants on that. Anyway, so how do we edit images with diffusion models? Well, one sort of the most basic way, and this is the image-to-image pipeline that you'll see in various implementations, is that normally when we generate with a diffusion model, we start from random noise and we iteratively denoise this using a prompt until we get an output image. With image to image, what we do is we start with an image, we add some noise to it, and then we denoise from there. So we do some of the denoising time steps based on optionally a new prompt, and we get a new output. But it has usually some of the, at least structure and colors of the input, and depending on how many steps we skip and how many denoising steps we do, how much noise we add, we can control the amount. So you see this done in papers, for example, like this SD edit, where they start with a very low-res stroke image as one of their examples, and then they show how they will add a bunch of noise to this, and then iteratively reverse that process using a diffusion model trained on imagery, and now you have this kind of output that looks much more realistic than the input. And they show this with different data sets. These are all, I think, unconditional diffusion models, but this kind of sets the scene for this idea. We take an image, optionally we modify it, right? So this is like my starting point. And then the way I get this looking more realistic is just to add some noise and denoise with the diffusion model and hope that the output looks more plausible. Another one that's done this is the so-called Magic Mix paper. Again, they're going to talk about inventing this completely new task of semantic editing, but they do this fairly well. You take a source image, you add some noise, you denoise it. Let's see if we can find the diagram in the paper here. Yeah, so you can start with random noise, denoise it with one prompt for some time, and then switch to a different prompt for the last few steps. Or you can start with an input image, you can add some noise to it, and then denoise with a new prompt to get something that has the same sort of overall structure and layout as the input, but tries to match some new prompt. And so the paper has lots of great examples of saying the more noise you add, the wilder your results are going to be, right? And there's lots of other things you can tweak. At some point, you've gone completely away from your original, but yeah, you can kind of play with those different parameters there. So lots of neat demos and pretty pictures. You just got to be a little cautious with some of the claims to be first, as with all of these papers. And often it's just that people aren't necessarily aware of the other work that's going on, or it's all concomitant, right? Everyone's having the same ideas at the same time. But very cool to see this idea of okay, I take an image, I add some noise, I denoise it with a prompt. So that's step one, but obviously this only gives us this global editing. We can't get too targeted. So it's great for maybe changing styles. So I want something drawn in a new style, but it's pretty tricky to have much control over the kinds of edit that we do. And so enter the first sort of major modification to this, which is just to say, well, let's add a mask. So a paper that does this really nicely, blended diffusion, where here, now we'd like to edit this image and add a ball. We can paint in a region where we'd like to do this editing. And you can see here we get a bowl or a bowl of water, a big mask for the background, and then they can edit the background. And so the idea here is very similar to the previous example. We're going to take an image, We're going to add some noise to it. But then what they do here is they use a mask. So they're going to also start with some completely random noise or a very, very noisy version of the image. They're going to denoise it with their new prompt for what should be in that area. And then they're going to mix it with a slightly less noisy version of the input image, blended according to this mask. This little operation here is combining the two so that inside the mask, we're doing our new edits, and outside the mask, we're just using our input image. And as you do this over the number of steps, by the time you get to the end, most of the image is unchanged because the mask is all going to be 0, so it's all going to be the same as the input. But we've somehow edited within that mask to get a new prompt. And so this is really great. It allows us to add new objects to images without changing the rest of the image. It allows us to tweak. They show some different examples here, tweak different things. We can just have the mask cover most of the image if there's only some of it that we'd like to keep. And you can also do things like edit the image slightly within that mask in the same way that we edited the whole image before adding noise and denoising, just to give it some new kind of hints as to how to denoise that area. So you can see here, they draw this kind of funky pattern. The whole of that is covered by the mask. And so when we add lots of noise to this and then gradually denoise, we get the original image outside the mask, and inside the mask we get this kind of, according to the model, plausible output given the prompt blanket. So yeah, pretty nice way to get some fine-grained control, and I like that implementation. But it does rely on the user having to produce this mask. Let's see. But with a mask, okay, so there's other ways that we can get that mask. One is to use existing models for segmentation. So this demo here uses clipseg, right, which is based on clip, but it does image segmentation. And so given a description of what we'd like to replace, I'd like to replace the spider in this image. Very cute spider, first record in Sim. Just as a side, I'd like to replace it with the fly. So the first step is to use clipseg to generate a mask. And then the second step is to do something very similar to this, where within the mask, we're now generating something new. You can update this further using a model that's actually trained to accept the mask as input. So I think, this one we'll talk about shortly. But something like the new in-painting model for Stable Diffusion with the Runway ML Stable Diffusion 1.5 in-painting version, this is trained to actually accept that mask as additional conditioning to make it even better and to handle things like edge artifacts and so on. Okay, even better, why use an external model to generate the mask when we can rely on the diffusion model to do it? So this diff edit paper, excellent paper, goes into doing the same thing where we have a caption that we start with, a bowl of fruits. We have a new caption that we'd like, a bowl of pears, and it's going to both generate the mask and then do this kind of blended diffusion in painting within that mask. And the way that it does this is really clever because it doesn't use a separate segmentation model. It uses the diffusion model itself to generate that mask. And you can see if we instead change this to a basket of fruits rather than a bowl of fruits, the mask is in the new region of the image and we generate exactly what we need there. So how do they do this? Well, the key idea is that if we take our image and we have two different versions of the prompt, one with zebra and one with horse. Then we add a bunch of noise to that image and try and denoise it, right? See what the model's prediction is based on those two separate text prompts. We can see, well, where does the model's prediction differ? And now if I said this is a horse and this is a zebra, chances are the background is not going to be too much affected by that, right? So the difference between the two predictions is going to be fairly small. Whereas a model trying to denoise this knowing that it's a zebra is going to predict something different to a model trying to denoise this knowing it's a horse. And so you can see here, this normalized difference is saying what's the difference between the two predictions, and you can do this over a number of time steps and so on. And this is what they use to then generate the mask. So it's really clever using this idea that when I denoise with two different prompts, my noise predictions are going to differ only in the places where those prompts are different. And then I can use that to highlight the area that I need to edit. So really great paper, lots of great examples that they show using this kind of automatic mask extraction. And I really liked, so this is something that was brought up in the Fast AI course. So you can also see some open implementations of people trying to figure out how to do this themselves with Stable Diffusion. So this is John Robinson has done an excellent implementation there. But on the forum, I know there's lots of other people trying different ways to generate that mask. What happens? How do we handle the latent part of Stable Diffusion and so on? But really great approach, and that's using the diffusion model itself to generate the mask and then using that kind of more standard in-painting approach to denoise such that you keep the content outside the mask, and inside the mask you're generating something new according to the new prompt. Okay, riffing on this in a slightly different way, we'd still like to have this kind of prompt-to-prompt editing, where we have two different versions of the prompt showing what we'd like to change. And the paper that introduced this, I believe, was this prompt-to-prompt image editing with cross-attention control. So there's a really great weights and biases report demonstrating some of the outputs, as well as a good paper that we'll dive into. And so the idea here is that we have an image and an original prompt, a photo of a teddy bear wearing sunglasses and having a drink. We change that to the same thing, but having a red drink, and it knows how to mostly change that component of the image. You can see most of the rest is still quite similar to the original, but not exact, right? The sunglasses are slightly different, the bear's nose is slightly different. Still, the focus is on that new region. And so the way they pull this off, they show different types of edit, right? You can downplay a particular word, you can swap in a different word in place of the existing one. So here, cat riding a bicycle, cat riding a car. Landscape with a house near a river, you can add something and a rainbow in the background. You can increase the importance of different words, switch in extra words, change the style, etc. And it's a really, really powerful suite of methods. This paper uses the Diffusion model, which is not publicly accessible, so all the images are extremely good, but there are open source implementations of this for stable diffusion as well. Okay, so how does this work? When you are generating at each level of whatever UNet or diffusion model is doing the actual denoising process, there's going to be a way to add in the conditioning, which is the actual text prompt. And usually this is fed through some sort of transformer model, right? Some big language model and turned into really rich representation. And then the way that that is injected into the denoising process is via something called cross-attention. So for every point in the image or for every spatial location, and depending on how far in the UNet you are, this will be different resolution, you will then compute your queries, but your keys and values, this is in the attention mechanism, will come from the prompt. And so for every pixel location, right, that's what this grid here is, we'll have an attention weight for every token. And so now we have our prompts, we can then swap out different parts of the prompt, but keep that attention map, keep the weightings of that attention map, or we can add in additional changes to the prompt. We can change the weighting of different attention, different features, so we can like double the attention weights for a particular token in the prompt. And this is really cool. And the reason it works is that when we are denoising an image or synthesizing an image from noise, if we look at which pixels have high attention values for which parts of the prompt, you can see that furry and bear, the attention on those tokens is high in this region and low in the background. Bird is low in most of the image and high in the small region here, right? And you can see the same sort of holds across the different time steps. Obviously, it's worse initially and gets better as the denoising is happening. And so this allows you now, if I swapped in dog for bear, then I'm going to use these attention maps to make this edit. And so it's only going to affect the image where those attention values are high, right? It's only going to edit within this region here. And so I can replace the bear with a dog without worrying about this bird also being replaced with the dog, for example. So really, really great way of getting additional control. And that's relying on this idea of cross-attention. And so some of the examples here are really cool. Let me find the one with cake here. So here they're generating using fixed random seed so that the process is all the same, and fixed attention maps, right? So the spatial layout of those attention layers are going to be the same. But now switching out lemon for apple, for chocolate, for bait in the prompt, you get all these lovely variations on this cake that still have the same overall structure, but we've made this very specific edit to say, I would like a Lego cake now. And that's very different to just generating with those different prompts. We managed to keep the overall layout, structure, the type of cake, the shape, etc. It's just that this is now made of Lego or brick or decorated like a monster. It's a really, really cool paper, really great idea. And you'll see this kind of cross-attention manipulation, I think, quite a bit going forward as a way to get additional control and also just to visualize where is the network paying attention to these different things. This kind of map is really cool to see how it's doing that denoising process and where it's paying attention to the prompt. So yeah, great idea. This weights and biases one has some good examples using, I think, stable diffusion. Good little explanation there, so I'll link that as well. Okay, so that's our still adding some noise to an image or starting from random noise. and then denoising, but now we're editing the cross attention rather than just using a mask. The final sort of class of methods for editing images is fine-tuning based ideas. And so one here is Imagic, I think was probably the first that I'm aware of. And the idea here is very different. In this, we're now not just doing this at inference time. We're actually going to fine-tune either the whole diffusion model chain or specific aspects of it. So some variants will only fine-tune, for example, the text embedding of the prompt or the null version of the prompt. Others will only fine-tune just the diffusion unit. Some will fine-tune that and the text encoder and the text embedding. But the idea here is that we first train the diffusion model to just generate the input image, right? So it's very strongly almost overfit to that input image. Then we're going to generate, and if we just generated with an unconditional prompt or with the same prompt that we started with, we get back the same image because it's so fine-tuned that it just always produces this image. Except that the insight in this paper is that, well, it doesn't necessarily always produce that image if you use a very high guidance weight to force it to also pay attention to the prompt. Then it's going to do its best to match the original image, but it's also going to try and match the prompt, right? And so there's this balance. And so now we can say, here's my input, a strawberry cake, a chocolate cake, pistachio cake, a wedding cake. It's matching as much of that input image as it can because it's been fine-tuned for so many steps on just that image, right? So the background, the platter, everything else is the same. But now we've got a new prompt, a strawberry cake, and we're also using a very high guidance scale to force it to also try and look like a strawberry cake. And so it makes this minimal edit. And so you can see here, they optimize the text embedding first, then they fine-tune the model, and then they generate with this fine-tuned model. There's some additional tricks that different people are trying in terms of exactly how you handle the text embedding. So you can go and read the paper for the details on that. But that's the core idea. We are overfitting almost. We're very, very strongly fine-tuning the model on a single input image, and then we're regenerating new images with different prompts and very high guidance scales, but the model still tries its best to also match the original. So that gives us another method of editing. The downside of this, obviously, is that you have to fine-tune the whole big model chain and everything. That's very memory intensive and compute intensive compared to something like the mask-based image-to-image style in-painting pipelines. But yeah, still pretty cool, I thought. I think this Unitune is another variant of that approach that's useful to compare and contrast. They show you, here's your input image, you fine-tune the model. The title here, fine-tuning an image generation model on a single image. So you fine-tune on this image, and then you generate with different prompts, and you're able to get different, like essentially variations of that image, different edits, which is the whole point of this. So both of those papers worth checking out. Some fun ideas from both, but that is our final method. So just to recap, let's go all the way back to the beginning. So we said our task is editing images with diffusion models, and we started with, well, just add some noise to the image, denoise with a new prompt. We said, what if we do that with a mask? That's slightly better because we control where. We said we don't have to do the mask manually. We can use an existing segmentation model or approach to segmentation like ClipSeg, or we can get the mask from the diffusion model like with diff-edit, really great. Or we can forget about masking, but we can modify the attention maps, the cross attention, to see which parts of the image are paying attention to different tokens in the prompt, and we can upweight some of them, downweight some of them, replace them, etc., to get that kind of control there. Or finally, we can take a diffusion model, we can fine-tune it on a single image, and then we can use that now to generate new images that are mostly going to match that input image, but with different prompts we'll hopefully also have some differences that we care about, like adding whatever edits we'd like. So that's a very broad overview of editing images with diffusion models. I hope you've enjoyed. Like I said, all these links will be in the description. So now it's your job to say which of those sounds interesting. Are there any that you'd like to try and implement yourself? Dig into that research. But hopefully, if you are considering, like, how do I edit images with diffusion models? Can these be used beyond just generating images from scratch? The big takeaway I would say is yes, and there's lots of different methods, and I'm sure this is only the start. And as we go forward, we'll see even more smart ways to refine this process to make it better and smoother and more accurate and more controllable. And this is very exciting for me because the more control we have as artists and users of these models, the more amazing things we'll be able to make. All right, I hope you enjoyed that. Leave any questions down below and we can discuss further. Otherwise, we'll see you in the next video.